section 6.6. So a trapezoid. Our graphic organizer shows us the way it's connected there. We know a trapezoid is a quadrilateral. And trapezoids have exactly one pair of parallel sides. So on our picture, we have our trapezoid looks something like this. So kind of a standard looking trapezoid. And our parallel sides, these two sides would be our parallel sides. The other two sides are not parallel. We call the parallel sides the bases. So that's going to be a base. That's going to be a base. The non-parallel sides are legs. And the angles inside we call the base angles. So our trapezoid has two pairs of base angles. We call the legs, the non-parallel sides are legs. And there's one other thing that we can tell about a trapezoid. So if we think of these two parallel segments and think of this side being our transversal, what do we call these two angles that are on the same side of the transversal between the parallel lines? When we talk about parallel lines, they're on the same side of the transversal between the parallel lines, so they're same side interior angles. And what do we know about same side interior angles for parallel lines? Not congruent, but supplementary. So consecutive angles along a leg are same side interior angles, but consecutive angles along a leg are supplementary. So if we go along the leg here, these two angles would add up to 180 degrees. So there's our trapezoid. We'll talk about trapezoid mid-segments a little later. We're going to talk about isosceles trapezoids and kites first. But that's so our trapezoid has one pair of parallel sides. Isosceles trapezoid. Isosceles trapezoid has a little bit more going on. So that's just below there on your graphic organizer. Isosceles trapezoid is a trapezoid with congruent legs. So on our picture, we have a trapezoid, isosceles trapezoid that looks something like this. So these two are our bases, the parallel sides are the bases, and our legs are congruent. couple of other interesting things happen when we have an isosceles trapezoid. So we said the legs are congruent. Each pair of base angles is congruent. So these two angles are congruent, and these two angles are congruent on an isosceles trapezoid. Another thing that happens with an isosceles trapezoid, since we drew this in there, I'm not going to draw them in. The diagonals are congruent. So if I drew in the diagonals would be the same length. And just like with a regular trapezoid, the consecutive angles along the leg are supplementary. So that's some of the properties of an isosceles trapezoid. And just like with our other shapes, now we can use these, now that we know about these, we can use them to solve other kinds of problems if the problem happens to involve trapezoids. So questions about our properties of our trapezoids. All right, let's look at a kite. Kite over to the right. Our last special quadrilateral. So a kite shows on our graphic organizer, a kite is a quadrilateral. With two pairs of consecutive sides congruent. No opposite sides are congruent. Congruent or parallel. No sides parallel. So on our picture there of our kite looks like so. We have two pairs of consecutive sides congruent, so that would be congruent. Those two would be congruent. The opposite sides are not congruent, and the opposite sides are not parallel. So the interesting things with a kite happen with the diagonals. So I'm going to draw in the diagonals. Diagonals go corner to corner. The first one, the diagonals are perpendicular. So diagonals make a 90-degree angle with each other. The other thing that happens is the longer diagonal bisects the shorter diagonal. So these two segments are congruent. And the longer diagonal bisects the angles of the kite. So if I drew these angles down here, those two angles are going to be congruent, and these two angles are congruent. So those are our properties of a kite. So questions about a kite. All right. What I want to do is do a couple of examples that have to do with trapezoids and kites. Then we'll talk about trapezoid mid-segments, and that's all we need to talk about today. So here's our first example. So we're going to say that this is an isosceles trapezoid. We'll call it ABCD. And we know that this angle is 75 degrees. We want to find all the angles. So I have one of the angles in this isosceles trapezoid, so if we put some marks on the isosceles trapezoid, these would be our bases, our parallel sides. These would be our legs that are congruent. And we want to find these angles. Well, what do we know in an isosceles triangle about the base angles? What do we just say about the base angles of an isosceles triangle? They have to be the same. They're congruent. So angle A has to be 75 degrees. Because the base angles are congruent. And what did we say about two angles along the leg of a trapezoid? They have to add up to 180. So 180 minus 75 gives me 105. So the measure of angle C and the measure of angle D is 105. So this one has to be 105, and this one also has to be 105. So our base angles are congruent, and along a leg, they're supplementary. So if we know one angle on an isosceles triangle, we can figure out, or an isosceles trapezoid, we can figure out all the angles. Questions on that example? All right, let's look at another one. So this one we have a little more going on here. And we're going to call this triangle ABC. And we'll call this segment DE. And that's 32 degrees, that's X degrees, and that's Y. And I'm going to say that triangle ABCD is isosceles. We want to find measure of angle x and the measure of angle y. Alright, so let's just look at the triangle first. We have this triangle, ABCD. The problem tells us that this triangle is isosceles. What does that tell us about these two sides of the triangle? They're the same. If these two sides are the same, what do we know about the two base angles of the isosceles triangle? They have to be the same. So these two angles are the same. All the angles of the triangle add up to 180. So how can we find these angles? We know one angle in triangle is 32 degrees. 180 minus 32 gives me 148. And we divide that by 2. And I get 74 degrees. Together, these two have to be 148 degrees for all the angles in the triangle to add up to 180. Each of these is the same. So I divide that in half, and I get the measure of angle y is 74 degrees. And let's see, I forgot to say one thing. That segment DE, you were right. Like segment DE is parallel to segment BC. So these two are parallel. So now we can look at this. So what kind of shape is that I just highlighted there? That's a trapezoid. These two angles are along the leg of the trapezoid, so they have to add up to 180. So measure of angle x plus a measure of angle y equals 180. So the measure of angle x is 180 minus 74, and that gives me 106 degrees. So I found this angle y by using the triangle. I found angle x by using the trapezoid. I get a 74 degree angle and 106 degrees. Questions on that example? Okay, let's look at a kite. I'm going to draw in the diagonals here. So we know we have a kite. We know that this angle is 40 degrees. I'm going to call this angle 1, and this, let me undo that, and this angle 2. And we want to find measure of angle 1 and measure of angle 2. Measure of angle 1 should be really easy. And the diagonals of a kite intersect each other at what kind of angle? 90 degrees. So this is a 90 degree angle. So all of those angles are 90 degrees. So measure of angle 1 has to be 90 degrees. Well, if this angle is 40 and this is 90, together they're 130. What does that leave for this angle up here? That has to be 50. And what do we know about the angles? What does the long diagonal do to the angle of the kite? Bisects it. So if this side is 50, what does this side have to do? 50. They have to be the same. So the measure of angle 2 also is 50 degrees. So these two, if I look at these two triangles, these two sides are congruent. We said that the diagonal bisects the short diagonal. So Those two sides are congruent. This side is congruent to itself. So these two triangles are congruent by side, side, side. So these two triangles are exactly the same. All the angles in these two triangles are exactly the same. Questions on that example? Okay. Let's talk about trapezoid mid-segments. And then we'll be done. Trapezoid mid-segments, a lot like triangle mid-segments, very similar properties. So trapezoid mid-segment joins the midpoints of the legs. So if we drew a picture of a trapezoid in its mid-segments, there's my trapezoid. We know that those two sides are parallel. Those are our bases. We're going to join the midpoints of the legs. So there's my segment that joins the midpoints of the legs. The midpoints mean that side's cut in half and that side's cut in half. So we'll call the trapezoid A, B, C, D. The mid-segment is segment EF. So a couple of special things happen when we have the mid-segment of the trapezoid. The mid-segment is parallel to the bases. So just like the mid-segment of our triangle was parallel to the base of the triangle, the mid-segment of trapezoid is parallel to both bases. So we're saying here that in symbols EF, parallel to segment BC, and segment EF is parallel to segment AB. And thinking back to triangle mid-segments, how was the length of the mid-segment related to the length of the base of the triangle? So if I drew a little picture here, here's my triangle and here's my mid-segment. How was the length of the mid-segment related to the length of the base? It was half. It was kind of like that with the trapezoid, but our trapezoid has two bases. So we have two things that we have to deal with. The length of the mid-segment is half, just like with the triangle, the sum of the lengths of the bases. And sum is telling us to do what with the lengths of the bases? Add. Sum means add. So if we're going to write in symbols, we would say the length EF is 1/2 the sum BC plus AB. So we're saying add the bases, divide by 2. So our mid-segment is half the sum of the two bases. We have to take both bases into account with a trapezoid. So our mid-segment joins the midpoints of the legs. Midpoint means a point right in the middle, so it's the same on either side. Mid-segment is parallel to each base, and its length is half the sum of the lengths of the bases. Add the two bases together, divide by 2, and I get the length of the mid-segment. So questions on what a mid-segment is? All right, let's look at an example using a mid-segment. And then we'll go over our All right, so we'll call this W, X, Y, Z, and this T and U. And we're going to say TU is the mid-segment. Segment TU is the mid-segment. We're going to say this length is 6x minus 12. This length is 2x plus 10, and this length is 18. And we want to find x. Well, this is the length of the mid-segment. We know the mid-segment is half the sum of the bases. So the mid-segment equals half, and I'm going to add the two bases together. 6x minus 12 plus 18. So let me take care of these parentheses first. So I have 2x plus 10 equals 1/2. I'm just going to combine like terms in here. 6x plus 6. So there's our equation we need to solve to get x. So what are we going to do here to solve this equation? How are we going to get rid of this 1/2? Multiply both sides by 2. So I'm going to multiply this side by 2. And I need to make sure that I multiply everything on this side by 2. So I'm going to put parentheses there. These cancel. 2 divided by 2 just gives me 1. And here I need to distribute. So I get 4x plus 20 equals 6x plus 6. And now we're home free. So I'm going to subtract 4x. So 20 equals 2x plus 6. Subtract 6. Turn it around. 2x equals 14 divided by 2. And x equals 7. So we knew the mid-segment, 2x plus 10, was half the sum of the two bases. That's how we set it up. Questions on that example? Okay. Homework. I'll write that down, then we'll go over, pass the folders back, go over our other homework. So there's the bookwork. There's also, I assigned on Power Geometry, the mid-chapter quiz. So on your online textbook, so you log in and you click the to-do button. So that's been assigned, so that'll help you review for the quiz tomorrow. So remember, you need to know about properties of quadrilaterals, and you need to know about the angle, all the angles of our polygons. Interior angles, exterior angles, all of those things. All right, so let me pass your